Hi guys, Larry Feldman with a lesson on slope and what's called RDQ, or right difference quotient, and how they are related. First of all, a little review about slope. Going back to your algebra days, let's say we have a line or a line segment like I have on the screen, shown in blue, and I have 2 points in green. The first point is x1 comma y1, and the second point is x2 comma y2. And you may recall that slope, which is indicated with the letter m, is y2 minus y1 over x2 minus x1. And slope is also referred to as rise over run, or delta y over delta x. And all slope is a number that explains how the vertical change compares to the horizontal change. A tangent line is a line that touches a curve or a function, mostly or usually a function, at exactly 1 point, exactly one and only 1 point, and it does not cross from one side to the other. So, for example, this would be, let's see if I can do a reasonable job here. It's not horrible. This would be a tangent line at this point. Okay, at this point, the red line is a tangent to the green function, or it's tangential to the green function at that point. Now, what if I wanted to find the slope of this tangent line? Now, I only know 1 point on the curve. I don't have, or I don't know any other points on this line. Well, in calculus, we start talking about what's called difference quotients, and there are several. Right difference quotient, left difference quotient, etc. Well, in this video, I just want to talk about the right difference quotient, and you can extend the information to the other ones, but we're going to utilize what's called the right difference quotient in order to find the slope of the tangent line. So let me clear this out. Okay, let's keep going with this type of analysis. We have the first quadrant in the xy plane again, only we're calling it f of x. We're calling the y-axis f of x. Let's add a curve, or a function in this case, like that. And let's assume that we want to find the slope of the tangent line at this point, and it has an x-coordinate that's simply labeled x. Let me do that again. That's x. Now what we're going to do to figure out the slope of the tangent line is we're going to pick a second point on the curve that is exactly h units away, or h units to the right of the first point. So the coordinates of this point, or the x-coordinate, is x plus h. So let's think about that. If this is 2, and I move h units to the right, and let's say h is 4, this x-coordinate would be 6, 4 plus 2. So I hope that's not too complicated. So we have x plus h, and on the y-axis, or the f of x axis, this is f of x, and this is f of x plus h. Okay? Now, we connect these 2 points with a line, This is called a secant line. A secant line is a line or line segment that connects 2 points on a function or graph. And I know that the slope of that secant line is f of x plus h minus f of x over x plus h minus x. In other words, this point has coordinates x plus h, f of x plus h. This point has coordinates x, f of x, and using our slope formula, we take y2 minus y1, so we have f of x plus h minus f of x over x2 minus x1. So that's x plus h minus x. Coming down here and simplifying, we get m equals f of x plus h minus f of x all over. Now notice these x's cancel, so we're left with h. And this is a very important equation, and we're going to use it to figure out the slope of the tangent line. This is the slope of the secant line, but as h gets smaller and smaller, meaning this second point moves closer and closer to the first point, we can get a very close, in fact an exact value for the slope of the tangent line. So we're going to do that next. Okay, so let's draw the first quadrant again. And our function. And let's say that we want to find the slope of the tangent line at this point. And let's pick a second point up here. And we'll draw the tangent, or the secant, which is right here. And as I mentioned, as we move this second point closer to the first, and this occurs as h gets smaller and smaller, notice what happens to the secant line. Now the secant line is here. Okay? And then let's keep going with this. Now let's move the second point there. What happens to the secant line? Now the secant line is here, which is very hard to see on this graph, but it's really getting very close to the tangent line. So let's do a quick example. Let's say that f of x is x squared, which is what I've graphed here, by the way, just in the first quadrant. So we're going to introduce a term or a concept called the derivative, f prime of x, which is the slope of the secant line, slope of the tangent line, and f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. This is one of the most important formulas that you'll find in calculus. So we've already talked about this part. Now I'm introducing the limit as h approaches 0, and that is nothing more than moving this second point closer and closer to the first point. In other words, h is getting smaller and smaller to the point where h is approaching 0. So let me clear this out, and we'll do an example. Let's say f of x is x squared, as we talked about earlier. So the derivative, which is the slope of the tangent line, is the limit as h approaches 0 of f of x plus h minus f of x all over h. And this is called RDQ, or right difference quotient. Now, let's look at f of x plus h. To figure that out, wherever there's an x, we substitute x plus h. So we have x plus h squared, which is x plus h times x plus h. Foiling, we get this. Now, let's keep going. F prime of x equals the limit as h approaches 0 of f of x plus h, which we just found here, minus f of x, which is this, all over h. Now notice, change colors here, that cancels with that. We get 2xh plus h squared all over h, which is 2xh over h plus h squared over h by splitting the numerator. That cancels with that. We get 2x plus h, because h squared over h is h. Now the limit as h approaches 0, what happens as h approaches 0? We're left with 2x. Now that's a really important answer, because what that says is that the slope of the tangent line equals 2x. And that shouldn't be a surprise, because the slope of the tangent line, which is f prime of x, depends upon the x value that you choose. So, for example, let me clear this out. F prime of x equals 2x. So f prime of 1, we substitute 1 in for x, is 2. F prime of 2 is 4 by subbing in here. And let's look at the parabola real quick. I'm not being very consistent with the colors, but notice that, let's say we have the x value of 1. This says the slope of the curve at 1 is 2. Well, does that seem reasonable? Well, why not? Actually, let's switch colors one more time. Why not? Let's say that's 2. What about at 2? That's right here. Is that reasonable? Well, let's see what happens. Notice the slope at 2 is much steeper than the slope at 1. Slope at 2, let me just summarize this. This is m equals 4, and this is m equals 2, which is right here. So that's the RDQ. That was probably a little bit advanced for some people, but I hope it made sense. If not, please contact me. Thanks. See you next time.